Real numbers, we use the letter R to represent real numbers, and these are all numbers that we know. So any number you can think of is considered a real number. In Algebra 2, you will start learning about imaginary numbers, but we will only learn about real numbers. So real numbers are broken then into two separate categories, irrational numbers and rational numbers. We're actually going to start from the bottom and work our way up because they get more complicated. So the natural numbers, we use the letter N. These are your counting numbers. So we start with 1, 2, 3, and go all the way up. Whole numbers, we get to use W. These are just like your natural numbers, only 0 is included. So 0, 1, 2, 3, so on and so forth. So the only difference between natural numbers and whole numbers is that 0 is considered a whole number, but not a natural number. For integers, we do not get to use the letter I, we use the letter Z. Integers are whole numbers and their opposites. So in math, opposites are negatives. So the opposite of 1 is -1. The opposite of 2 is -2. So these start -2, -1, 0, 1, 2, and then they keep going in both directions. So all three of these, there are no fractions or decimals. Rational numbers are pretty much any number we can think of. For rational numbers, we use the letter Q. So up here it says all fractions and decimals that end or have a repeated pattern. So anything that you can write as a fraction is considered a rational number. So, for instance, 3/4, 3/4 is a rational number. 0.3 repeating, so 0.33333 forever and ever, is a rational number because we can write that as 1/3. Even things like 3/17. If you put that into your calculator, you'll get a really yucky looking decimal, but we can still write it as a fraction, so it is considered a rational number. Almost all numbers we work with are considered rational numbers. Now, later we're going to classify numbers, and here's what you need to know. If a number is an integer, that also means it's a rational number. Now you can say these aren't fractions or decimals, however, you can write these as 2/1, 3/1, so on and so forth. So we don't have to write it as a fraction, but we can. So if it's an integer, it is automatically a rational number. If it's a whole number, it's automatically an integer and a rational number. So wherever you land here, all of the top ones also are included. So, like I said, these are almost all the numbers we're used to working with. Irrational numbers, we use the letter I for. So right up here, these are decimals that never end or have a repeating pattern. There's a very common number in math, which we don't really think of it as a number, but it is. Pi is a number. We usually just say it's approximately 3.14. But the truth is the decimals just go on for ever and ever and ever, and they never stop. All right. Any non-perfect square root. So you'll see square root of 2 all the time. There is nothing that you can multiply by itself to give you 2. So lots and lots of square roots are irrational numbers. The square root of, let's say, 24. There's nothing you can multiply by itself to give you 24. Now, that doesn't mean every single square root you see is automatically an irrational number. So, for instance, if I have the square root of 25, oh wait, 5 times 5 is 25. So when I see this, I need to turn it into 5 to decide which of these it is. All right, so don't just automatically assume a square root means it's an irrational number. So down here, we need to name all the sets that it belongs to. We don't have to put R for real numbers because we know all of the ones we work with are going to be real numbers. So when I start, I always start and ask myself, is it a natural number? So number 1 is 30. 30 would be in here, so yes. So since it's a natural number, that means it is every single one of these up above it. All right, again, no, it's not a fraction, but I could write it as 30 over 1 if I wanted to. All right, so once I write natural numbers, sorry, this is really fuzzy. Once I write natural, I can write whole, integers, and rational. Negative 11, not a natural number, not a whole number. Those are all positives. It is an integer though. So since it's an integer, it is also a rational number. Number 3, it already has a fraction in it. Okay, this is a mixed number. So if you remember, you can change the mixed number into an improper fraction by doing the outside number times the bottom number, add the top number. So 5 times 7 is 35. 35 plus 4 is 39. So this would be 39 over 7. You don't have to do that, but if it's helpful to see that that's a fraction, then you can do that. So this is only a rational number. Square root of 21. So first you need to ask yourself, is there anything I can multiply by itself to give me 21? The answer is no, you can't. So therefore, it is an irrational number. So I. It's also good to know where the square root sign is on your calculator. So you can type in square root 21 equals, and again, obviously this stops because it's on a calculator. It can't go on forever and ever, but there is no pattern or anything like that. 0 is not a natural number, but it is a whole number. So whole number, and then that means integer, and that means rational number. 9, okay, so the negative, don't worry about that right now, square root of 9. 3 times 3 is 9, so this actually becomes negative 3. So again, some of these you're going to have to simplify before you choose which number system it's part of. So negative 3 is an integer, which therefore means it's a rational number. Now, a lot of people see number 7 and say, oh, that's a fraction, so it's automatically a rational number. Although that's true, you need to realize that this actually divides to 2. So we're looking at the number 2, not the number 6 over 3. So 2 is a natural number, which changes it, or which also means a whole number, an integer, and a rational number. Number 8, we already talked about above. Pi is always just an irrational number. As soon as you see a decimal, you know it cannot be natural, whole, or integer. All right, since it's repeating, that's part of the rational number definition. So a rational number, if you have a repeating decimal. This 5 doesn't make it an integer. Again, number 10 looks pretty yucky, but you need to see if the square root of 144 comes out to a non-decimal. So you can type it in, and it is. So this actually becomes 12 over negative 3. That then divides to negative 4. So we need to use negative 4. That's an integer and therefore a rational number. So again, don't just assume when you see a square root sign that it's going to be an irrational number. Oops, sorry, I put Z for integers. Number 11 is the same thing basically as number 9. As soon as you see a decimal and this one stops, that automatically means rational number. Number 12, you can type that in your calculator, but you shouldn't need to. Hopefully we know that anything divided by itself, no matter how weird it looks, is always going to give us 1. Anything divided by itself is 1. So 1 is a natural number, which means it's a whole number, an integer, and a rational number.